Everyone, this topic is going to be an unique because regarding gold exploration or any kind of mineral exploration, alteration play a significant role. And in this video, the basic things I am not going to discuss because those things are known. But please stay tuned. You can understand what is the significance of this particular video. Lot of new things you'll come to know because since alteration is a very generalized term, you must be knowing already there is two style of working with alteration. One is qualitative aspects, another is quantitative aspects. In qualitative aspects, you must have come across some terminology like potassic alteration, phylic alteration, okay, these kinds of argillic alteration. These kinds of alterations are just done by seeing under petrography, under naked eye, how that chemical alteration occur based on mineralogy. Some particular parent mineral is getting altered into different new stable minerals. For example, sometimes chlorite is getting developed, or sometimes chloritization of biotite, or feldspar is getting sericitized. These kinds of alteration are indeed important, but they are indicating a qualitative aspects, simple mineralogy and stability. For example, what particular mineral X is stable under certain condition, if that X is becoming Y, so that itself indicates change in condition in which Y gets stability. Likewise, from feldspar to sericite or chloritization of biotite, there are so many other these kinds of alteration. Similarly, that hematitization, chloritization, sensitization, so many things you can remember and recall. But apart from that, there are another aspects, that is quantitative aspects, in which specifically you can estimate based on geochemical data. If whole rock geochemical analysis is done, for example XRF data, you will be understanding the importance of that. For example, if you have major element oxide data, by using that, there are certain chemical certain equations in which you can directly estimate the intensity of alteration. For example, chemical index of alteration, chemical index of weathering, Hashi-Gushi weathering, chloride carbonate pyrite index, CCPI, Ishikawa alteration index. So those things already I have discussed extensively. In this video, further deeper insights you will be getting. So pH, EH, those things we will be discussing. Based on that overall understanding of alteration, qualitative, quantitative aspects, further what implication we can derive. So gold can form complexes with different ligands. Ligands means what? Any types of electron donor. For example, Cl minus, okay? Like that, these kinds of ion, or even it may be some molecule as well. I'll show. So those ligands under varying physicochemical condition may influence transport, precipitation in particular geological environments. So those geological environments we can understand from alteration, and directly it can give very much significant information in narrowing down targets. So understanding the stability and diffusional condition of various gold complex is essential for economic gold exploration. And alteration zone can give clue on different type of geochemical environment and corresponding elemental stability, pH, temperature condition, etc. Such information may help in understanding the stability of gold deposition. It is this same, I am just giving an example of gold, so same analogy can be utilized for other type of metal also, okay. So the stability of gold complex, and just metal to metal, their stability range will be different, their oxidation reduction potential will be different, but fundamental concept will remain same. So therefore stay tuned. So gold generally U+, U3+, these kinds of cationic form is available, and they bound to ligands such as chloride, cyanide, thiosulfate, bisulfite. So these ligands are most important for gold. So similarly, there are other ligands which can be important for other type of elements or other type of metallic elements especially. So in this context, one thing you must know, the stability constant. For example, if you understand this reaction Au plus 3 elemental just ionic gold plus 4Cl minus ligand, so it will be forming this AuCl4 minus. Okay, so this is a complex. Now to understand the stability, you know that formula K, AuCl4 minus concentration divided by concentration of Au3 plus multiplied by concentration of chlorine Cl minus. Okay, so gold transport is largely dependent on these kinds of stability. Okay, gold complex and its precipitation occur when these complexes become unstable due to environmental change. Means if AuCl4 minus this complex is available, gold cannot be precipitated, it will be moving with fluid. So there should be such a condition in which this AuCl4 minus should break down into Au, and that means elemental gold and chlorine. So that will be determined by this stability constant K. You can see higher the value of K, higher will be AuCl4 minus. So therefore to get elemental gold, K should be lower, and more importantly this K is represented logarithmic scale. Okay, so a higher log K means more stable complex, less likely to dissociate. So therefore again I am repeating, higher stability constant, that means gold remain dissolved in solution and less likely to precipitate, whereas lower the stability constant, gold complex is more prone to be broken down and leading to gold precipitation. So always that K value should be lower. Okay, now meaning of ligand, as I have told, it is a very basic thing. I can expect that it is known to all. Ligands are donor species, electron donor especially. Okay, where electron is available, just for example Cl minus. So electron is extra, one Cl is extra, one electron is extra. Similarly cyanide, Cl minus. So these are ligands. It can easily attract gold or any cation. Okay, these are anion. Anion will be always trying to attach with cation. Likewise, there may be complex as well, HCO3 minus. Likewise. Now, how gold deposition occurs? Of course, gold must be precipitated. That means different factors can influence the precipitation of gold. Among these, alteration is one of the important phenomena. And alteration means what? Alteration means something change, and that change can influence gold precipitation. Okay, so Au precipitation is higher when a gold complex becomes less stable. So that less stability must be achieved. That means K, log K should be lowered. Whatever the condition, if alteration lowers the log K value, definitely gold will be precipitated. So what are the parameters which can influence to lower the K value? That is the important question. So more stable gold complex keep gold in solution and delaying precipitation. So therefore the main influencing factor, alteration is a broad term, but what are the parameters which governs alteration? That is change in pH. For example, acidic to neutral condition destabilize AuCN complexes. So acidic to neutral condition, those are very important prerequisites. Changes in temperature, sudden change like cooling of hydrothermal fluids reduces stability of gold complex. Decrease in ligand concentration by some sudden another parallel phenomena, which if that ligands are consumed, for example loss of HS minus, Cl minus, Cn minus, those ligands for example are being utilized by different other complex, other cation, then what will be happening? That for gold, these kinds of complexing agents are not available. So therefore gold will be likely to be precipitated. Similarly, redox changes, oxidation reduction reactions can destabilize gold bearing complexes. So I will be showing this this table you can see gold complexes, their relative stability and typical condition under which gold diffusion occurs. So primarily for gold, I am just concentrating on gold, but that these fundamental things, as I am repeating, we will be utilizing for other elemental metal as well. So gold is having mostly CN, cyanide is very much important, cyanide complex, thiosulfate, then chloride and bisulfite. And more importantly, gold often occurs as native gold, that itself indicate colloidal gold. Okay. So if we see the relative stability, that is K value log K, very high stability means high value of K. And low value of K means low stability, and low stability means most likely to be precipitated by as gold. So by seeing this table, you can understand that colloidal gold is very much important for getting higher gold value. Primary gold ores, often quartz vein, within quartz vein directly native gold is very commonly observed, because those are in colloidal state and their stability K value is very less. Okay, then moderate complex is bisulfide, gold chloride complex. They are also very important in orogenic, Carlin type, epithermal type porphyry deposits. So they are mostly that bisulfide, chloride, they are very much important. Okay, so therefore those kinds of complex whenever available, that will be indicating definitely gold occurrence. Whereas cyanide complex, you see relative stability is very high, thiosulfate is high. So cyanide is utilized for gold leaching. It is different issue. That is also equally important, but for in industry, not in geology. Geologically it is detrimental. Whenever cyanide present, it can attract gold. So when that will be concentrating gold, some certain process, mineral process engineering, their cyanide is very much important, because it will be attracting gold and make complex with gold, and hence from the system gold will be removed, and later other some techniques should be there which can take out that gold from cyanide complex. So therefore, in order of geological importance, colloidal stage is important, bisulfite and gold chloride is important. For industrial point of view, thiosulfate and most importantly cyanide complex are very much important for taking out of gold from the system. And then again, you should understand that the stability, okay, very low, moderate. So wherever very low stability, that K value is there, that will be indicating gold precipitation. I hope that much is good enough for this video. Thank you.